are we going to start with? Do you have any topic which you want me to start with, or shall we have just a continuation of that?
Um, I wanted to do electrolysis.
Okay, you want to do electrolysis.
Yeah, because I don't understand it.
Okay, fine. So we'll start with electrolysis today. Have you done it in school before?
Yeah, I did it in school, but I never understood it.
Okay, fine. We'll do it here. Okay, electrolysis. Now, um, electrolysis. What is happening in electrolysis?
It is used as an electric current to break down the compounds
It is a
containing iron.
okay. Something is happening, that is breaking down of compounds. Okay, lysis
Yeah.
means to break down.
Okay.
Okay, lysis
Yeah.
means to break down. And with what are they breaking down? With the help of electric current.
Okay.
Okay, electro comes to the term electric current. Got it?
Yeah.
Okay. Now, ionic substances have charged particles, right? What do you understand by the term ionic substances?
The ones with the ions.
Okay, they have ions, right?
Yeah.
Okay. Why do ions have charged particles?
Um, because they move around. So,
Okay, and how are they? No, I should frame my sentence as how do ions are formed from atoms?
ions form atoms.
How do ions are formed from atoms?
I don't know.
Okay, so we'll see that also, right? I just
Yeah.
told you atomic substances contain charged particles called ions. Now, if you have a atom, like I say, sodium atom, okay? The number of
Okay.
electrons present in the outermost shell of my sodium atom, along with the all other electrons, will be my atom. But if I am losing any electron or am I gaining any electron, will give me a charge. Positive charge I have given away, right?
Yeah.
Given away an electron. So this is my atom now. This is my ion now. Okay? This is
Yeah.
how atom is converting itself into an ion. Now we were
Uh,
talking about ionic substances, right?
yeah.
Like example, if I said lead bromide, PbBr2. This is lead bromide. Okay, now if you see this
Yeah.
compound lead bromide contains positively charged lead ions. This has positive charge, and negatively charged bromine ions, right? And
Yeah.
when we apply electrolysis to this one, what is electrolysis? It is a process by which these ionic substances, through which these ionic substances are broken down, right?
Yeah.
With the help
Uh,
of electric current. So what we are doing is we are passing electrolysis through this. Okay. Now,
Yeah.
once we pass electrolysis, it's just breaking down. Electricity is flowing of the electrons. Now, what happens? They get divided. How? Or they get broken down in the form
Yeah.
of Pb plus and Br minus. Right?
Yeah.
What happens? Covalent compounds, they cannot act as electrolytes. So for any substance to work, compound should contain ions. Okay,
Yeah.
compound must have ions. That means it should have a pair or a lone pair of electrons which can give or which is ready to
Take.
share. Yes, right? It should be,
Yeah.
electron should be there to share the, okay, share. That means compounds must have ions for electrolysis to work. Okay, and
Yeah.
covalent compounds, they do not act as an electrolyte. Do you know what are covalent compounds?
The one with shared pair of ions, electrons.
Okay, a covalent compound is a substance or is a molecule containing one or more covalent bond. Okay, now your covalent
Yeah.
compounds cannot act as electrolytes. Okay, why? Because they have neutral atom. Do you know what an electrolyte?
No.
Okay. Now, electrolyte is a substance when molten or in solution will conduct an electricity.
Okay.
Okay, substance which conducts electricity. Okay, this is
Yeah.
a electrolyte. So, covalent compounds cannot act as a solution because they have neutral atoms.
Yeah.
Okay.
Yeah.
Now we were talking about right? Now when electricity is passed through this the lead bromide is broken down in the form of lead and bromine. But we will see exactly what is happening over here. Okay?
Yeah.
Do you want to write it down, note it down, anything from here?
Oh yeah. Yeah. I'll just see that now.
Yeah.
Yeah. I've done that.
Done?
Yeah.
Now for an to work, we said that it is working under an electric current, right?
Yeah.
How that it works? Let's see with an example over here. Okay. Now we are going to see electrolysis is working over here. Okay.
Yeah.
Now what are these? These are electrodes. Okay.
Yeah.
Two electrodes. And here I have conducted electricity of negative charge, here the positive. So the one which is and connecting over to the negative will be my negative electrode.
Okay.
Okay, and the one which is connected to the battery to the positive will be my positive electrode. Okay, so I
Yeah.
have a negative electrode, I have a positive electrode. Now what is happening during electrolysis? Okay, if this is my solution, what do we do is, if this is a solution of my, this is an ionic solution, we place these electrodes inside like this. Okay,
Mhm.
place them this way and we conduct electrolysis. Now what happens? I said it is ionic substance. That means it will have positive charge ions, it will have negative charge ions as well, right?
Mhm.
So initial stages, they both are mixed together, but when electrolysis is happening, they get separated. What happens when separated? The positively charged ions, all the positively charged ions move to the negative
Negative.
electrode. So here I will have positive ions. Okay.
Yeah.
So I have my positive charged ion to the negative electrode. And what is happening to the positive electrode here? All the negative charged
Negative.
electrons are moved to the positive electrode. So I write negative
Yeah.
charged ions. Okay. Here
Yeah.
they receive these electrons and they are reduced. Negative
Mhm.
electrode, what is happening? Receive electrons and reduced. Okay, whereas what
Mhm.
is happening over here, here they lose electrons
Yeah.
and are oxidized. Now tell me, what do you understand by reduced and oxidized?
Reduction occurs when positively charged ions gain electrons,
Yes. So when they
and
are
then the other one is
receiving
when
or
negatively
gaining,
charged ions
yes. Okay. So when they are receiving or gaining electrons, we term them as reduced one, and when they are losing electrons, they are termed as the oxidized one. Okay. So you
Okay.
understood what is happening with the two electrodes over here?
Yeah.
Okay. Then,
I'll just write that
okay, fine. You finish it off, then I'll move.
down. Okay.
Okay, I just mentioned their names. When we're talking about a negative electrode, it is known as a cathode, and the positive electrode is known as the anode.
Anode.
Okay, so mention that also.
Okay. Yeah, finished.
Okay. So you remember what I told you about electrolytes?
Yeah.
Okay, what are electrolytes?
A substance which conducts electricity.
Okay, substance which is conducting electricity. But to
Yeah.
conduct this electricity, they should have some qualification, right? It's like only if
Yeah.
you're qualified, you can apply for a certain post, right? For jobs and all. Like that, for any substance, to be an electrolyte substance, they have this test for conductivity. Okay, what do they have?
Yeah.
They have test for conductivity. What is happening over the test of conductivity? They include a sample of the substance in a circuit that is containing a source of direct current. Okay, I'll write it.
Yeah.
We have a okay, a sample of a substance. So if this is my sample of a substance, it is connected to a circuit. A circuit is something which will have, okay, now this
Yeah.
circuit is a source of direct current. What do you understand by a direct current?
It has like a straight so like the current goes directly to
From
the.
a battery. Have you seen a battery, a normal battery?
Oh yeah.
Battery or a cell or a power pack. That is a direct current. Okay.
Yeah.
So they are attached to a direct current and a bulb. So in the end, what do we have is a bulb. Okay.
Yeah.
Also, we can connect an ammeter. What do you understand by ammeter?
You have an ammeter to check the amps, the current.
Which is a device which is used to measure electricity, right?
Yeah.
with a bulb or ammeter. Okay.
Yeah.
Now, if there is current which is flowing from this substance, they will flow, but this substance, it should be in a molten or dissolved form. Okay. No solid
Yeah.
substances are involved in this. Only molten and dissolved. When, if you know that there is current flowing through the substance, it will flow through the direct current,
Mm-hmm.
which will show us the switching on of this bulb, or it will show us a reading on that ammeter.
Yeah.
Okay, so this is the test for conductivity. So if
Okay.
we have positive result in a bulb or an ammeter, that means this solution is an electrolyte.
Okay.
You understood how substances are undergoing for test for conductivity?
Yeah.
Okay, fine. Now we'll see how electrolysis of molten salts are occurring. Whenever there is or a dissolved ionic compound, okay, and it is conducting electricity, we have new substances. Okay, so whenever
Yeah.
there is a molten or a dissolved ionic compounds which is conducting electricity, we have new substances. So I'll write new substances form when a molten or dissolved okay. Now we'll
Yeah.
take the same example. Okay, what example we took was lead bromide, right?
Yeah.
PbBr2, lead bromide. Now this lead bromide can be used to produce bromine and lead, right? Because it is having two elements inside them, lead and bromine. By how? We'll see that. Okay, what are we going to do is now we are going to conduct electrolysis of molten salt, that is lead bromide. So initially my first stage here will be lead bromide is solid in nature.
Okay.
Okay, and tell me, can I conduct electrolysis on solid substances?
No, it's only molten and dissolved.
Yes, molten and dissolved. That means I need to melt this one first, solid lead bromide.
Yeah.
Okay, so solid lead bromide is placed in a crucible. Okay,
Yeah.
have you conducted experiments in your lab?
Yeah, we do.
So you must have known what a crucible is.
What?
Crucible is, you know what is a crucible?
Oh, yeah, yeah, yeah.
What does it look like?
It's like a I can't really explain it, but it's like a box kind of thing.
Yeah, a bowl kind of thing, right?
Yeah, yeah, yeah,
Okay. So there is a crucible, and inside this crucible, we are going to place the lead bromide, which is a solid. Okay. Then
yeah,
what are we going to do is we are going to heat over a Bunsen burner.
yeah,
You have seen a Bunsen burner?
yeah, yeah.
Okay.
You change the flame on it as well.
Yes. So we are heating it over a Bunsen burner. Okay, this way. So we are going to heat till this lead bromide is melting. Okay, and
Yeah.
until it melts, we have to heat it. So I'll write until it melts. Okay, until it melts. Now,
Yeah.
what's happening? Now we observe that it has now been melted. Okay, this
Yeah.
solid is now melted. Now what we do is we insert two electrodes, right? Because we need electrodes for the particles to get attached to it into this
Yeah.
molten electrolyte, and we
Yeah.
pass a direct current into them. Okay,
Yeah.
else insert two electrodes, pass current. Okay, so this is a
Yeah.
procedure of how I'm going to conduct an electrolysis of molten salt, that is of lead bromide.
Yeah.
Okay, now why are we selecting carbon electrodes?
Um, because is it because they're molten?
Okay, carbon electrons are chosen because they have a very high melting point.
Oh yeah, yeah,
They have a good melting point and they are inert with certain products. Okay,
yeah.
this is my procedure. So you write it down and then I'll move on to the next slide and explain you what is my observation.
Okay. Yes. So
You're done with that?
yeah,
Okay. So now we have conducted an experiment, okay? I told you
yeah,
the procedures of how am I electrolyzing it, right? Okay.
yeah.
Now we are going to see the results. Now the results. What are the two electrodes?
The positive and the negative, so the cathode and the anode.
We have a cathode and we have a anode.
Yeah.
Okay. So what is happening in the anode?
There's a positive electrode. The negatively charged ions move to the positive electrodes.
Yes, what?
Sorry.
Can you please repeat it there?
Oh yeah. Anode, the negatively charged ions move to the anode, which is the positive electrodes.
Yes. Okay. So anode, which is a positive electrode, cathode, which is a negative one. Okay. The
Yeah.
observation what I get over here is I have bubbles of brown gas. I have
Yeah.
bubbles of brown gas, and in cathode, what I have is a silvery liquid metal, okay, which is present at the electrode underneath the electrode, okay, silver
Yeah.
liquid metal. Now, what is the explanation to these? Bubbles of brown gas indicates that it is the bromine vapor. Okay, bromine,
Yeah.
that is Br2. And silvery liquid metal, it is the lead which is being produced, Pb. Okay,
Yeah.
this is the observation of my anode and my cathode. Did you understand
Okay.
experiment along with my observations?
Yeah. Yeah.
So this is the observation and this is the explanation of that observation. Now actually it is very easy to predict the products of the electrolysis because we know what electrolytes we are using, right? In this sample
Yeah.
we had used lead bromide. So we were actually, we know that it is positive here and it is negative here. And what is my result? So we can guess from our electrolyte itself, right?
Yeah.
Now this elements which I'm talking about, they can be split easily. Like the metal is formed at the negative electrode, right? So
Yeah.
electrode, this is my metal over here because this is where the positive metal ions are getting attracted, and non-metals are formed at the positive.
Anode.
Yeah. Okay.
Yeah.
Okay. So like this was one example where we spoke about lead bromide. Like that, for anode, we can give you one more example of that of chlorine. Okay, chlorine is
Yeah.
there, oxygen. So these are all the non,
Not bad.
right? And
Yeah.
metals, if I need to say, we have zinc and we have aluminium. Okay, these are other examples of metals and non-metals which gets attached to the anode and cathode.
Yeah.
Okay, so you
Okay.
write it down and then we'll move on to the next type of electrolysis. We saw
Okay.
electrolysis of molten substances, right?
Yeah.
And this was the result of it. Next, we'll go on to the next topic. So before that, just write it down.
Okay. Okay. Yeah, I've done that.
Done?
Yeah.
So we saw of molten substances where we are taking in a solid, we are melting it, and then we are conducting an experiment, right?
Yeah.
Okay. Now electrolysis of ionic solutions. Here we have ionic solutions, right? That means they are
Yeah.
already in their aqueous part. So electrolyzing of aqueous solutions. Now they are more complicated. Okay.
Okay.
I have to mention that electrolyzing aqueous solutions of ionic compounds are more complicated than electrolyzing molten compounds, right?
Yeah.
Okay. Why? Okay. The question is, why are they more complicated? Although they are there in their aqueous solution, why they are like more complicated than the molten compounds? And the answer here is because water molecules, they provide hydrogen ions, right?
Yeah.
Aqueous solution means a solution which is a
Dissolve.
substance mixed with water. So now when
Yeah.
talking about water, water has hydrogen ions, right? They produce
Yeah.
hydrogen ions as well as they produce hydroxide ions.
Yeah.
Okay, so we are getting extra ions to the ions which are already present in a compound. We are talking about ionic compounds. This ionic compounds itself has ionic charges, right? In
Yeah.
addition to this, we are producing extra compounds of extra ions of hydrogen and hydroxide. And that is a reason they are quite complicated over here.
Okay.
Okay?
Yeah.
Okay. So this is one simple thing. So once if you are done with this electrolysis of ionic solutions, then we can carry out with the normal procedure.
Okay.
Clear? Okay.
Yeah.
Now we'll see what is happening at the negative electrode and what is happening with the positive electrode.
Okay.
I'm talking about a negative electrode. Now, negative electrode. Negative one is the
Cathode.
cathode. Okay. Now, here we saw that the metals are getting attracted, right?
Yeah.
Here, metal ions or hydrogen ions, they are positively charged. Okay. So, whenever we get
Yeah.
metal or hydrogen during electrolysis, it is depending on the position of the metal in the reactivity series. Have you heard about reactivity series?
Yeah.
Okay. What is reactivity series?
It's a series of which metal is reactive than the other one.
Yes. It shows us the most reactive to the least reactive one. Okay. Reactive in all forms. So metal will be produced if it is less reactive than hydrogen, right?
Yeah.
A metal. Metal will be produced is less reactive than hydrogen, and hydrogen will be produced if metal is more reactive than hydrogen. Clear? So when are we
Yeah.
getting hydrogen and when are we getting metals? So we'll write
Yeah.
compounds. Let's say potassium, starting with potassium, sodium, lithium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, gold. Okay?
Yeah.
This is my series of reactivity elements. Now, how it goes is, the most reactive starts from here it ends with the least reactive. So gold is the least reactive and potassium is the most reactive.
Yeah.
Okay. Now just imagine if we are conducting an experiment or electrolysis of copper chloride. So we have copper over here, right?
Yeah.
We have a copper chloride. Now copper chloride solution will produce copper at the negative electrode. Why at the negative electrode? Because it is least reactive, right?
Okay. Yeah.
The same with a sodium chloride solution, it will produce hydrogen because now it is a metal, right? See, metal will be produced if it is less reactive than hydrogen.
Okay.
This is the example of it. Okay, so you note it down with a negative electrode and then we'll move on with the positive electrode.
Okay. Yeah, I've done.
You're done?
Yeah.
So you have understood what is happening with the negative electrode?
Yeah.
What is happening? Okay, very clear about it?
Yeah.
Okay, now we'll see what is happening with the positive electrode. Okay. So we saw in negative electrode that the positions or the electrolysis depends upon the reactivity series, right?
Yeah.
In positive electrode, if a negative ion from the ionic compound, like example, we are talking about chlorine or bromine, okay? These are the negative
Yeah.
elements, right? Then that element is produced, okay? And if the negative ion is a complex ion, if I am producing these ionic compounds, then the element
Yeah.
produced is the same thing. But okay, simple one.
Oh.
But if we have a complex ions like NO3 minus or SO4 2 minus, CO3 2 minus, okay? When we have
Yeah.
these kinds of complex ion, what is oxygen? Okay, they,
Okay.
they produce oxygen instead of the element over here. Okay, clear? So what we'll do is we'll make a table and I will jot down what is present in the negative solution and the elements given out. Okay,
Yeah.
negative ion in solution and here is the element given at anode. Okay, now if my negative solution has chloride, that is Cl minus, my element will be, so this is chloride. Okay, what I have is chlorine. Okay, see, I showed you when I have these kinds of ionic compounds, I will be getting the same element. So chloride will give me chlorine, right? Similar,
Yeah.
bromide will give me
Oh,
bromine. Similar way, if I have iodide, I will have iodine, right? So these were
yeah.
simple ones. Now we'll come to the complex ones. Let's suppose it is SO4 2 minus, which is a sulfate. Okay. So what will be present here? Oxygen,
Yeah.
right? If I take another ion solution, let's say nitrate NO3 minus, which is considered as nitrate, then we have, again we have is oxygen. Okay, so you understand
Okay.
this present now in negative ion and the element which is given out.
Yeah. yeah.
So I'll make another table where I will put some common ionic compounds, the elements released at positive and the negative electrode. Okay, so I want to
Okay.
continue writing. This is just for some additional information which I'll be writing it now. So these are the wherein we are writing the additives. Okay.
Yeah, I wrote that.
You have done that.
Yeah.
So next is we have to start with half equations, ionic half equations. So that will take a long time. So what I want to do is go through whatever we have done till today.
Yeah.
Okay, from the
Okay.
starting, the one which we started with electrolysis, and tell me
Yeah.
if you have any doubts regarding this.
Okay.
Just go through it.
I don't have any doubts with this one.
No doubts as far as we have completed.
Yeah, I know what. Yeah, I understand.
Okay, so fine. What I'll do is I'll just search out for some questions and give you for homework for your next class. Okay.
Okay.
Okay. Just give me a moment. these are some of the questions I want you to solve for your next class.
Okay.
These are the options. Good.
All right. Okay.
So have you noted down?
Yeah. Just last question.
Yeah.
Okay. Yeah, I've done.
Done?
Yeah.
Okay. So revise whatever we have done. Answer these questions. We will discuss this in our next class.
Okay.
Okay, then bye. Thank you.
Bye. Thank you. Bye.
You are currently the only person in this conference.